This is Dr. Prasanna Kumar, working as an assistant professor in Government First Grade College, Tumkur. Actually, we are going to in this PPT in this session we are going to deal with mechanics and the special theory of relativity. In this paper, I am going to deal with rotational motion. In this rotational motion, I am going to deal with calculation of moment of inertia of a solid cylinder. Calculation of moment of inertia of a solid cylinder. The main objective of studying this is to calculate moment of inertia of a solid cylinder about its own axis and to create an interest in calculating moment of inertia of a solid cylinder about an axis passing through its center and perpendicular to its own axis. This is the main objective. Moment, this is the cylinder. Let us consider, we are going to consider the many number of layers in the cylinder. In that delta x is one such element. The outermost layer from the center of axis is R2. This layer is at a distance of R3. This layer is at a distance of R1. Moment of inertia of a solid about its own axis. This is the own axis. Cylinder PQ be axis of hollow cylinder of length L. L be the length of the cylinder. M be the mass of the cylinder. R1 is the radius. R1 is the radius of internal radius. R2 be the external radius. Let the cylinder to be divided into large number of thin coaxial elementary cylinder and consider one such cylinder of inner radius x and outer radius x plus dx. All the particles of such cylinder are at the same distance x from the axis of rotation PQ. Volume of this elementary cylinder is 2 pi x dx into L. Volume of the given cylinder can also be written as pi into R2 squared minus R1 squared into L. Mass per unit length of the cylinder can be mass per unit volume of the cylinder can be written like this. This is the volume of the cylinder. This is mass of the cylinder. Hence, we can write the expression like this. Mass of the elementary cylinder. Mass of the elementary cylinder. X dx is the element. Hence, we can write 2 pi x dx into L. If we substitute and simplify, we can write the expression like this. Moment of inertia of a cylinder can also be written as moment of inertia of a cylinder. This is known as mass of the elementary cylinder and x is the distance from the axis. Hence, mr squared we have written in the last PPTs. Here we have written it as what you call that x. Therefore, mx squared it is, that is moment of inertia can be written ultimately as mx dx divided by r2 squared minus r1 squared into x squared. See, the moment of inertia of the whole cylinder about PQ is obtained by integrating the above equation from x is equal to r1 to x is equal to r2. Here r1 is known as internal radius, r2 is known as external radius. If I apply the if I apply the limits of integration for the moment of inertia, we can write r1 to r2 m into r squared. That is m is 2mx dx divided by r2 squared minus r1 squared into x squared. If we integrate and simplify the above equation, these two m r1 squared, r2 squared, these are all mere constants, hence we can take it out. X is the only variable, x cube dx will be remainder. If we integrate, we will get x to the power of 4 divided by 4, r1 to r2. 2m divided by r2 squared minus r1 squared into r2 to the power of 4 minus r1 to the power of 4 divided by 4. Moment of inertia is given by m into r1 squared plus r2 squared divided by 2. Solid cylinder having the inner radius, inner hole, r2 is equal to r and r1 is equal to 0. Therefore, the expression is m into r2 squared divided by 2. This is the expression for solid cylinder. Next, the moment of inertia of a solid cylinder about an axis passing through its center and perpendicular to its own axis. This is axis passing through its center. This is the axis perpendicular axis. The hollow cylinder composed of angular rings of same external and internal radii R2 and R1. R1 is the internal radius, R2 is the external one respectively. Consider one such elementary ring of thickness delta x. One such, this is like what I call that in Kannada we are going to call that as sautekai. Over slice of each cucumber. Alright. We are going to consider one such slice. Over. Alright. Consider one such elementary ring of thickness delta x at a distance x from the center of gravity of the cylinder O. Surface area of the elementary ring is given by pi into r2 squared minus r1 squared. Here, volume of the elementary ring. In the last expression we have shown, in the same manner we have written pi into r2 squared minus r1 squared into delta x. Mass of this ring is pi into r2 squared minus r1 squared into delta x, m divided by pi into r2 squared minus r1 squared into L, m dx divided by L. Its moment of inertia about the diameter can be written as m divided by L dx into r1 squared plus r2 squared divided by 4. Moment of inertia of this elementary ring about parallel axis through center of gravity O of the whole hollow cylinder is m divided by L r1 squared plus r2 squared divided by 4 dx plus m divided by L dx into x square. The moment of inertia of the whole hollow cylinder can be obtained by integrating the above expression between the limits x is equal to minus L by 2 to L by 2 and x is equal to plus L by 2, minus L by 2 to plus L by 2. If we integrate, we are going to get I is equal to m divided by L r1 squared plus r2 squared divided by 4. It is a mere constant, hence we can take it out by applying the limits of integration minus L by 2 to plus L by 2 dx plus m divided by L minus L by 2 to plus L by 2 x squared dx. If we substitute and simplify, we can write like this. This is written as it is. This is written as it is. If we integrate this, x we will get minus L by 2 to plus L by 2 plus m divided by L into x cube minus L by 2 to plus L by 2. I is equal to m divided by 4L R1 squared plus R2 squared ml squared divided by 12. I is equal to m into L squared divided by 12 plus R1 squared plus R2 squared divided by 4. We will get. Next, in this session, what all we can expect the multiple choice questions we have listed. We have listed those questions. You can gone through those questions and you can find the answers for those questions. These are the another 3 questions. These are the expected answer for the multiple choice questions which we have written here. Next, the questions are like this. Explain the moment of inertia of a body and obtain the expression for moment of inertia of a solid cylinder about an axis parallel to its length. This may be the expected problem. This is one more question. Obtain an expression for moment of inertia of a solid cylinder about an axis passing through its center and perpendicular to its length. We have to derive the expression for moment of inertia of a solid cylinder about an axis passing through its center and perpendicular to its length, that we have shown in the last slides. These are the what you call that books which you can refer. C. Narayana Reddy, Professor Lakshmi Narsi Narayanappa, Dr. Anand Kumari Basavareddy. They have written the book Concepts of Physics, Spurti Publications, first edition 2016. You can also go through C.L. Arora, Mechanics and Properties of Matter. One more book is there. It is written by us, we people, as a group. We have written the book under the guidance of our PhD guide, Professor H. Nagabhushana, Professor C. Somashekaraya, Ramakrishna ji, Dr. J. Malashappa and myself. That is Fundamentals of Physics, Mechanics and Special Theory of Relativity, Sapna Book House. This book is available in online also. These are the things which we have to study in this session. By this, I want to conclude what you call that this session. Here in this session, these are the important questions, main questions. They may appear in your examination. We have to prepare for explaining the moment of inertia of a body and to obtain an expression for moment of inertia of a solid cylinder about an axis parallel to its length. About an axis parallel to its length. Here in this question, we have to derive the expression for moment of inertia of a solid cylinder. We have to obtain the expression for moment of inertia of a solid cylinder about an axis passing through its center and perpendicular to its length. Thank you one and all.